Again, these are where we're going to have to use our compound and continuous interest formulas. So as a quick refresher, for compound, it's A equals P, our initial value, which is 1 plus the rate over the number of times compounded to the NT. Okay, and then here, the balance is 70,000. So this is not what we invested, right? So it has a balance of 70,000. We're going to assume it earns a rate of 0.06 quarterly. How long will it take to reach? All right, so this is going to be where we're starting at. So this will be our initial value, 70,000. We want to end up with 100,000. And then we have 1 plus the rate is 0.06 over quarterly is 4. And then 4, and we don't know the time here. All right, so this is different from the other ones in the sense that we're trying to solve for the exponent. So what we're trying to do is we are going to get the exponential part by itself. We need to divide. So we have our 100,000 divided by 70,000. And the thing you need to be careful here, I'm going to write this part out. For these problems, you need to make sure that you're not rounding until the end because it could change your amounts significantly. So, if your calculator was rounding to a certain digit, you might want to go ahead and change it back to float. And so again, we could put this number here. I had it just to that many decimals, but I'm going to go ahead and just reduce the fraction. So we just get 10 sevenths. So we have 10 sevenths equals, and then we can add this again, 1 plus 0.04 divided by, 0.06 divided by 4. But again, I want to make sure that that's an exact value. So for the time being, I'm going to put 203 over 200. This is a terminating decimal, so technically you could put that and it would be just fine. But this is to the 4t. So if I want to solve for t, I'm going to take the log of both sides. So I'm going to use a common log, but you could use a natural log. You could use log base 10 sevenths if you wanted to. It doesn't matter. So I get log of 10 sevenths equals log of 203 over 200. Now that's to the 4t, but I'm going to use the power rule. So 4t is going to come here, okay? So that's going to go away. What I can do now is I can divide both sides by 4 log of 203 over 200 to solve for t there. All right, and then we got to type this big guy in. So then t equals, and at this point, this is where I can go ahead and round my final answer. So I'm going to use the feature, my numerator over denominator, and I have log of 10 sevenths over 4 log of 203 divided by 200. Okay, and so what does it tell us? We're going to round our years to 2 decimal places. So if you're unsure, you're not like the best rounder, which grading, I know that most of you are not. And so we get 5.99. All right, so 5.99 years for number 63. And then for 64, this is compounded monthly. So for this one, we're going to triple our value. We're going to do in 10 years. And we're looking for, and it's going to be compounded monthly, and we're looking for the interest rate. So this time we're looking for R. If it's going to triple, then what's going to happen is we're going to have 3 times whatever our principal amount was. So we don't know what that amount is. We just know we have triple that amount. And then we have 1 plus R over, and we're doing it monthly, and then 12 times 10. So the p's will cancel out, and we can go ahead and take the log of both sides. So I have the natural log of 3 equals the natural log of 1 plus r over 12 to the 120. But this 120 is going to come in front, okay, by the power rule. So then I'm going to divide both sides by 120. Okay, so I get the natural log of 3 over 120 equals the natural log of 1 plus r over 12. Okay, but I need to get this by itself, right? So I need to evaluate this. So this is tricky here, but if I create these, if I make these exponents, so for example, like if I have like 2 equals 2, and I create any base I want, I'm like, I'm going to have 3 raised to the second. Well, then that's going to be also 3 to the second. So I created a base, and since these two were equal, this would be the same. I want to get rid of this log. I'm going to create a base e. So now these are exponents here. And what happens is I get e to the natural log of 3 over 120 equals, all right, when you have the base to the log of the base, then it's going to be 1 plus r over 12. So we can subtract 1. So I'm subtracting 1, and that equals r over 12, and I'm going to multiply by 12. And so that equals r. So then we just got to type that guy in. So I have 12 times e to the natural log of 3, and the parentheses there, divided by 120. Come back down, minus 1, and parentheses. So my rate is going to be, is it 2 decimal places here? Yeah, we're going to need a little bit more here. So I'm going to go back to mode and float. And the reason why we have to do this is because this is our rate. We need to continue going. So we need to move the decimal. So so if r is 0.11036, that's really going to be 1104. So the rate is 11.04%.